Folks, Mrs. White here. Today's agenda is to go over our homeworks. I'm sure you saw that in Google Classroom I uploaded each of the images I'm going to show you, and I'm going to talk about them here. But again, if all you need to do is really look at those keys and use those to correct your homeworks, that's fine. I do want to remind you that our quiz is due, okay? Our quiz is going to be due Wednesday by midnight, so you need to make sure that that is turned in. This will be the last quiz that you're submitting this year. There's not a Chapter 12 quiz. We're just going to end that right up with a test. So it's really important that you get it in and that you do well. I want to remind you that your lowest quiz grade is dropped at the end of the year, and your year one grade is really what's being reported out to UMA. And so it's important that you do the best you can always, right? But that is our last quiz. We want to make sure that you're ending that really strong. So let's take a look at section 11.1 right now. 11.1 started off with us looking at two samples for the first time, okay? So we had to look at two samples, and we were specifically looking at proportions. Now, on that quiz and on the test we're going to be taking, you're not going to know if you're dealing with a proportion or if you're dealing with a mean, an independent or dependent mean, or standard deviation. Just by the order that it's in, you need to actually read the problem and think about it. Okay, so we're going to treat each of these, even though this whole sheet is proportions. You want to keep in mind that those can be intermingled with any means that are dependent or independent. We'll have to make sure we can make that decision, and standard deviations. So let's take a look quickly. We're not going to talk through all of these, but we can take a quick look at some of them. So in number 3, they just wanted you to identify if it was dependent or independent, and qualitative or quantitative. So this first one was dependent because the second spouse, was only chosen because the first one was, right? So that second group was dependent on the first. And it is measuring salary. Salary is numbers, and it's how much money you make. It's a how much, so it's quantitative. In number 9, you had to test a proportion using hypothesis testing. Big idea here is that it's just different keystroke. You're still doing z-score, but instead of having just like a p or a p hat, you're dealing with p1 and p2 because you have two separate samples. So the keystroke for this would be test stat to prop to test. Okay, so two samples you're dealing with. You're dealing with a prop, and then it's not a to test, sorry, z test, because we're doing a z test because z-score is our test statistic. Okay, so stat test 2 because we're dealing with two samples, prop because they're proportions, and then z test. If you are still kind of working towards finding your critical values and your p-value, which you need to be for this quiz, your critical value is found table 5, looking at the very bottom of that page. Okay, when you're dealing with a z-score, you don't use the whole page. You use just the little bottom left-hand corner. Based on the results, whether you're doing it classically or with your p-value, which I have right here, it was true. Our inequality was true, so we do have enough evidence to reject the null and accept the alternative. Number 17 is similar. We're doing a hypothesis test again. Once again, you're using P1 and P2, and P1 should have been larger. Okay, that's what we were testing. So again, if you're looking over at doing this in the classical method, you get your test statistic, which is your z-score. Okay, again, you can get that number just by running your 2-prop z-test. You get your test statistic. You're going to compare it to your critical value. That critical value, again, is found table 5 at the bottom. And then if you do the p-value, then you just set that as less than your level of significance. Either way, we get that yes. If we're looking at classically, it is in the shaded region. We get yes, it is less than 0.05. So there is enough evidence. Again, you would reject the null, and you'd be able to accept the alternative. Number 21 had us creating a confidence interval. And then let's see to whether it has at least, okay. So you're really just doing the confidence interval. So again, very similar to before, it's a keystroke. You're going stat test, and then you're going to go to, because there's two samples, prop, because we're dealing with proportions, and then z int. It's not z test. We're not testing a hypothesis. We're doing an interval, so you do z int. That's what we're looking for. 2 for the two samples, prop z int. And you end up getting this. Then you want you to interpret it. So you would say something like, I am 95% confident that the difference between the proportions of males and females that have at least one tattoo is between negative 0.005 and 0.0428, for 0.0482. Sorry about that. Lastly, we're looking at figuring out sample size, okay? And sample size did not come up in any of the other sections, so you would only be using this when we're dealing with a proportion. That is really important for you to know. It's also important for you to know that this formula is not included in the insert in your book. So this is something you just got to kind of commit to memory as you're studying for our Chapter 11 test. What's nice is that Chapter 11 test is going to be just Chapter 11, not 11 and 12. So you're going to take the proportion from your first sample and the kind of its complement, and you're going to multiply those together. Then you're going to add to it the proportion from your second sample and its complement. Again, you're adding those two pieces together. Then you're going to times it by this chunk, and this chunk works whether you have previous data to work from or not. It's Z of alpha divided by 2 over E, and then the squared is on the outside. So this formula actually, this little chunk right here is super duper 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 similar to what you saw in Chapter 10. It just had different stuff on the outside because it was dealing with only one proportion, not with two different samples. So to find that Z-score, again, you're going to the back of your book in Table 5 and looking in the bottom corner. Your margin of error they give you as being 3 percentage points. So you don't make it 3, you make it 0.03. And then make sure after you do the division, you square it. So we end up running all those calculations. You can check your work with mine. And we get that if you do have a prior estimate, you're going to need about 1,400 people. Okay, 1,406 people. You always round these up. Okay, every single time, if this is a minimum amount of people and you get 0.01, you have to round up, have to. If you are not given any prior estimates, you always just use a 0.5 instead of having to do all these calculations. But this piece is the exact same, okay? You just take that number and you divide it in half, and you end up with this. 2,135 people, making sure that, again, you always round up. When you are not given a prior estimate, this number will almost always, in fact, it will always be larger than if you have a prior estimate. And that's why it would be worth doing all of this work, right? If you're running an actual statistical analysis and you're having to do sampling, you want to sample the least amount of people, because although crunching these numbers might be more work, it's not actually more work in the long run, because gathering all that data from this many people versus this many is really where the big difference is. If you have questions on 11.1 or any of the other sections, please feel free to join me for office hours tomorrow. Our last lesson for this week is going to be a review for the test. I would like to just hold that. I'm going to do a short 15-minute video, and I will hold office hours the following day, but I would really encourage you folks, if you have questions ahead of time, to hit up office hours this Wednesday so that you're not just solidifying stuff for the quiz, but you're also studying for the test. Let's look at section 11.2. This only had two problems, number 3 and number 7. 11.2 had you looking specifically, again, at two samples, but this time we were dealing with dependent samples. It's also called matched pairs, okay? So these are going to be an X and a Y that have to go together, and what you're going to do is you're going to subtract them in your list 3 and then just use list 3 for all of your calculations. So you can see how that kind of worked out here. So the first thing you're going to do is put this in L1, this into L2, and then create in L3, you're just going to subtract the 2. And they told you which order to subtract them here. Once you have this L3 column in your calculator, to find the difference mean, or the standard deviation of your difference, you could do 1-var stats of L3. You could totally do that. But you also, knowing that you're going to do hypothesis testing, could just run your hypothesis test. And if you run your hypothesis test, you end up getting these values out anyways, okay? So if I did run my 2, because I have 2 samples, and I just do the t-test using L3, okay, I'm going to get that my average difference, which is the same thing as my sample difference of L3, is negative 1.6143. And the standard deviation of my difference, which again, because it's L3, is the standard deviation of X, is going to be 1.9152. If you continued on with that, you'd have your classical and your p-value. Your p-value is less than your level of significance, so you can reject the null and accept the alternative. In the classical method, your test statistic, okay, which here is your t-score of your null, because we're dealing with a mean, it's always a t-score. It's negative 2.23. We need to find this value right here. So in order to find a t-value, okay, not the t-score necessarily, but this t-value that corresponds to the area here, you need your degrees of freedom. There were 7 pieces of data, so there were 6 degrees of freedom. And then I need to go to the 0.05, and it needs to be to the left, which means my number is going to be negative. Okay, since this is symmetrical, all we do is just make it negative. So it's going to be, if I look up degrees of freedom 6, area of 0.05, and then just make it negative, I'm going to get negative 1.943. So clearly my test statistic is in the shaded region. We're good to go. Yes, it's in there, so we can reject the null. There is enough statistical information, or statistical evidence, excuse me. Next, compute a 95% confidence interval. Again, because we have L3, this is exactly what you would do, okay? If you were in chapter 10, it's the exact same keystrokes, you're just taking L3, which is the difference. So you're gonna go stat test T interval, and you get your 2 pieces and parts out for that. In number 7, you're given it. At first, it looked like a lot. This really, it just is 1 through 12. They just separated it into 2 tables. So under L1, I would put all these pieces of information. Under L2, I put all the second. Identifying that they were matched pairs, I knew that I was going to have to do L3, which was going to be L1 minus L2. But anyways, first question, why are these matched pairs? Okay, you're measuring 2 different measurements, but those 2 measurements are off of the same round. Okay, so without having this, you can't have this measurement without this measurement because both of them are off of the same bullet. Okay, and so that's why it's a matched pair. Both of those are interrelated to each other because they both came from that same bullet. Next, is there a difference in the measurement of the muzzle velocity between device A and device B at a 0.01 level of significance? They're telling you to hypothesis test there, and they're telling you it is normal and there's no outliers, so you don't have to check for them. So when we are doing, and this is what can be tricky, okay? When we're doing our null and alternative for a dependent mean or the matched pairs mean, you have to always look at the difference. So what this means is the average of our distances, okay, is going to, or excuse me, our differences is going to be 0. So if there's no difference, the difference would equal 0, okay? Now here they're saying, they ask you, is it going to be different? So that would be two-tailed, okay? And we would use cannot equal, so our differences would not equal 0. They could be bigger than 0, they could be smaller, it doesn't matter. We're testing if they're just different. Again, we use the same keystrokes as before, so we're doing 2 t-tests, but we're making sure L3 is plugged in as our data. And then we're going to calculate our p-value, your test statistic. Again, to get the t-score, your negative, you need to split those areas in half since it's two-tailed. So instead of looking at 1%, you're going to look at 0.5% here and 0.5% here, making one positive and one negative since it's symmetrical. And here, if you decided to do p-value, you get your p-value. It's clearly not bigger than 0.01, and this value is not in either of our shaded regions, so both of those answers are null. There's not enough evidence to accept your alternative. You just keep your null, okay? Then we're going to construct a 99% confidence interval. Again, same keystrokes as before. And then lastly, draw a box plot. I drew it on my graphing calculator, and then if you click the trace button and press over and stuff, you can actually get the specific values for each of these. You'll see that I did that again, I think in section 11.4. So either way, they ask you, does this visual evidence support the results obtained in Part B? So each of these sections of a box and whisker plot, folks, represents 25%. So if we're looking at Part B, which is, if we're looking at only a 1% difference here, does that interval seem to fit? And the answer is yeah. I mean, it doesn't seem like it's going to be very probable to fall in that whole shebang. So let's move on to section 11.3. In 11.3, we were looking at means again, but these are going to be independent, so we're going to treat them as 2 separate samples. We're not going to have a third column that's going to represent the difference. So in this instance, when we start doing our hypothesis testing, we're going to be using our mean of our first sample and the mean of our second sample. We are not going to be looking at the difference between the two because it is not matched pairs data, okay? So in question 1, they just had you do some hypothesis testing based on this table. Here, they didn't give you raw data, they gave you calculations. So you need to make sure that when you go into the 2-sample t-test, you go into stats and you plug in this data where it belongs, okay? So in sample 1, this would be your X bar of your 1, your standard deviation of your 1, your N with your sub 1, okay? All of those have to get plugged in for 1 and then these for 2. There's work for all this stuff, so you're welcome to look closer either way, depending on how you did your hypothesis testing using classical or p-val. There's not enough evidence, so you keep your null. To do the confidence interval, it just tells you to construct it, not to interpret it. So again, different keystroke, we're doing 2-sample t interval. So again, it's still a t interval. It's just telling you have to have 2 samples, okay? Just like in our hypothesis testing, 2-sample t-test. And again, it's a t and a t because we're dealing with means. It's a z when we're dealing with proportions. Let's move down to this problem. I don't love drawing box plots. So again, I drew them on my calculator and then I just clicked the trace button and pressed over so that I could get each of these specific values so I'd be able to compare them. It's hard to compare them without knowing what those numbers are. So if you look closely, the minimum here is 25, and the lower quartile here, it looks like it's 36 or 31. It's something in the low 30s. Oh, definitely 31. Duh, there's my number line, okay? This minimum is at 17, and this one, if you look here, isn't even at 30. So if we were to compare this 25% and this 25%, I mean, this whole 25%, almost entirely 25% of those who did not have that the ramp meters were off on went slower. So it's pretty clear to say that, like, that's a lot of the data. A quarter of the data is potentially slower than every piece of data here when the ramp meters were on, okay? So I would say that's kind of what it's letting me know. There are no outliers, but is there a difference in speeds? I'd say, yeah, I think that the lower 25% of those that are off were a lot lower, okay? And I kind of put that little summary right here. Next, I wanted you to test your hypothesis. So you could do it like a difference if you wanted to. I put my null up here with a 0, but you don't have to do the difference. So if this makes more sense for you, do it this way. So if this represents our 1 and this represents our second sample, so our sample 1, sample 2, our null is that there's no change, that the two things are identical. But we want to test if our ramp meters on means that they're having a higher speed, okay? So is M1 actually greater than M2, or are they technically pretty close and the same? So if we run that hypothesis test, we get a p-value of 0.048, which is pretty gosh darn close to 0.05, but it is less than this, so we would say yes, they are faster, okay? But see, it's pretty close to that level of significance there. If it was 0.05, actually, if I look back at this problem, I think I made a mistake on my homework. If you look right there, it says it should be 10. Okay, so this should be 0.10. Again, that's still lower than 0.10. So yes, it's true. Yes, we can say that the ramp meters do make or allow you to travel faster. The last problem has us just looking at, do you have more leisure time if you do or don't have kids? And instead of doing a hypothesis test here, they just wanted you to construct and interpret a confidence interval. So again, we notice it's 2 samples. We know that they're independent. So to do our confidence interval, we're going to go 2 samp t, because it's means, and int, okay? And that's how I got these two numbers. Because it says interpret, I did write something out. I didn't write it the exact way I should have. I should have said we are 90% confident that the difference in leisure time between adults with and without children is between 0.72 and 0.23 hours, okay? It's really important that when we're dealing with a mean, you don't just give decimal values. Those values mean something. It's actual hours. So the adults that don't have kids have between 0.72 and 2.3 more leisure hours than those who do have kids. So that can kind of lead you to believe that if we did a hypothesis test, I mean, that's a pretty significant amount of time, that 2.3 hours. I'd say that depending on your level of significance, it's probably going to reject the null that they're the same and accept that people that don't have kids have more time. Last homework we had was 11.4. This one covered standard deviations, and it introduced to you this F curve, which has kind of a skew to the right. It actually was really similar to chi-squared. And finding the values for that are a little bit trickier. It's a new table in your book. It's like some A pages, I think like A16 or A19. If you had any problems finding those, please let me know, and I can either record a short video with my ebook or an actual video or attend office hours. Oh my gosh, yes, and I could answer those questions for you. Okay, so either way, here we're doing, because we're looking at standard deviation, we have a level of significance of 0.05, so we write it as the F value for 0.05. We always do, your first sample would be represented in your numerator, so we put the degrees of freedom for that, and then your second sample and your test statistic would be in the denominator, and so that would go here, the degrees of freedom for that. And this is how you find it in that table in your book. So you look across the top for your numerator, you look across or down the left-hand side for your denominator, and then you match up where the 0.05 is. When you're doing hypothesis testing for it, okay, again, since F is our test statistic, that's what we're looking for in the name as we look for it in our calculator, okay? So first things first, we have two samples. They're independent of each other, which we need to know. They do mention the word random right here, and they do actually tell us it's normally distributed, so we don't have to do any other graphing or anything. We are doing standard deviations, so in my head, once I see that we're dealing with standard deviations, and it even tells us, does the treatment group have a higher standard deviation? I know that I'm going to be dealing with my F curve for this chapter, okay? So I did outline which group I was putting for my 1 and my 2. So I said the treatment group was 1 and the control group was going to be 2. So my null is that those two groups are exactly the same. But my alternative is that those who had the treatment have a higher concentration standard deviation in their blood than those who are in the control group. Okay, so since it's greater than, it's going to be right-tailed, so it's going to be right over this way. Again, you can go classical, you can do p-value. If you are doing classical, you have to be able to find those values in your book. Either way, to get your test statistic here, you still want to run the stats test that you need to. So again, in this one, you're going to go to your into your stats menu. You're going to go over to test. You are going to go down to the option that says to sample F test. Okay, F because F is our test statistic. We choose T when T is our test statistic. We use Z when Z is our test statistic, okay? But we're dealing with the F curve with standard deviation, so we go down to sample F test. From there, we get this as our test statistic. You can also get your p-value from there. It was 2.6 with a little error and a negative 13. That means I moved this decimal point forward 13 places. So there's going to be 12 zeros there. That is a really small number. It is clearly going to be smaller than 1%. Okay. Here, to find my F value right there, I'm going to do the F score of 0.01. They didn't have 64 for numerator and denominator, so you go to the closest value they do have. For the numerator, the closest was 60, and for the denominator, the closest was 50. And that gave me this value of 1.91. And again, 6.9 is in that shaded region. So you can see I did write my summary for that hypothesis test too. There is enough evidence at a 0.01 level of significance to say that the treatment group has a higher standard deviation for the retinal concentration than the control group. Okay? So this summarizes a little bit of everything from chapter 11. I know that it's kind of funky to have another curve added in there partway through. Make sure on your quiz you are very thoughtful about if you're dealing with a mean, if it's independent or dependent, right? Because those are two totally different calculations and two totally different ways to write null and alternative hypotheses. Again, if anything's unclear, I keep pushing office hours. I haven't had anyone show up, which is fine. But this is where I get to tell if you're actually getting chapter 11 or not. And that will let me know how much review I need to do for Thursday. Thursday's video, I'm planning on just going over the answers to the chapter 11 quiz. So if you turn it in late, I'm going to ask you to do the redo. So please make sure you do turn in the chapter 11 quiz on Wednesday. If not, I am not going to accept it late. I will give you the retake instead because I do want to go over those answers. I think that would be a good review for the test. I also will release on Thursday for you the note sheet that Miss Ross has allowed her kids to use on the big test before. I spoke with her. She's cool if you want to use it on the Chapter 11 and the Chapter 12. She's not teaching stats this semester, so her class isn't impacted. But she did it in the fall, and so I want to give you the same opportunity they had. In between now and then, if you have any questions, please pop me an email. Let me know what's up. Thank you, folks. Talk to you later.